Hello, this is Sagar Malam. I am working as a senior project manager at Ecosmob Technologies. Today I am here to show how we can leverage React Native, WebRTC and OpenSIPS in order to build cross-platform softphone applications. Building softphone applications has been a tedious job because you have to build that in various native languages. With React Native and WebRTC, it can be simplified a lot and you can build those applications much faster. So let's start with the general introduction of React Native. So all of you already know what is React Native and may already have used it already, but still I would like to talk about few of its salient features. The biggest one is hot reload. You can write code once and write everywhere, so it saves the cost, and also it is easy to learn. Talking about WebRTC, so WebRTC is a RTC standard which mandates quality and security. It supports DTLS SRTP, it supports data channel, it has a capability to adapt in various networks, and along with that it can also be used in order to share the screens and also any kind of messaging if you want. Both of these technologies, React Native and WebRTC, has its own limitations, and that's where OpenSIPS comes into the picture. So talking about OpenSIPS is a diverse and multi-purpose SIP server, and it can be used to build anything that you want in the SIP world. So here OpenSIPS will be used in order to extend the capability of WebRTC to support UDP, TCP, RTP protocols with the traditional PBX. So let's talk how we can leverage these three technologies in order to build high quality and high standard softphone application. Alright, so let's look at the big picture. On your left hand side you can see SIP.js and WebRTC. So SIP.js will be used for setting up and tearing down the sessions through SIP. WebRTC will work as a media engine. In middle you can see there is OpenSIPS and RTP Engine. They will do the translation if required from the WebRTC mandated protocols to non-WebRTC mandated protocols. For example, DTLS SRTP to RTP, WSS to UDP or TCP. There is also ExpressJS and MySQL. So ExpressJS can be used by application to store the subscriber data into the database, like if they prefer UDP, TCP or whatever protocol they want. And OpenSIPS can use ExpressJS to fetch the data from the database and act accordingly. You can also see FCM and APNS. So they will be used mainly to send the push notifications to the application as and when required. So whenever application is in kill state, OpenSIPS can use FCM or APNS in order to wake up the application to restart the connection and then do the necessary communication. Okay, so let's look at the registration flow. Application sends register request to OpenSIPS. OpenSIPS forwards the request to the PBX. PBX sends back 200 OK. Now when OpenSIPS will receive 200 OK, OpenSIPS will insert data of that subscriber into the database of USC Registrant. When the registration expires, in this case after 3600, OpenSIPS will send a registration request to the PBX, and after that all the subsequent re-registration requests which we get, OpenSIPS will get from the application, they are not relayed because OpenSIPS will stay registered on behalf of the application. Unregistration flow is similar to registration flow. When application sends unregistered request, OpenSIPS instructs USC Registrant to unregister, and that's it. So at this point of time, all of you must be wondering, why do we need USC Registrant? You can use something like Meet Registrar to do the same job. So why do we need so much complexity? Answer is that these days lot of OS, they don't allow application to keep running for a long time. So what could happen is that application is killed and PBX thinks that application is unregistered, but actually from the user perspective, application is still logged in and should be registered. So due to this limitation, it is possible that after some point of time, application will not receive any kind of incoming calls. So that's where OpenSIPS and USC Registrant does the job to always stay registered with the PBX, and whenever PBX wants to send a call to the application, OpenSIPS receives it and it can use FCM and APNS in order to wake up the application, restart the connection and then forward the call. So this picture shows the incoming call flow. On your right hand side, you can see the state of the application, in which state the application was and at what point of time. So as you can see that PBX sends an invite to the OpenSIPS, and at that point of time application is in the killed mode, so it cannot receive the invite. OpenSIPS recognizes that and it sends the push notification depending on the type of the application. If it is Android or iOS, it will use FCM or the APNS. As soon as push notification is received, application will send the register request to the OpenSIPS, which actually restarts the connection between OpenSIPS and the application. OpenSIPS then forwards the invite to the application, and everything is as usual after that, meaning that application will send 180 ringing, which will be relayed back to the PBX, call will be answered, and there will be RTP session between PBX and the application. So far we saw what is happening under the hood from the server side for receiving the incoming call. Now let's take a look at what happens on the application side. So in this diagram you can see various components which play critical role in order to achieve what we are trying to achieve. OpenSIPS will send push notification to the application. Now depending on the OS, Android or iOS, React Native Call Keep or React Native Firebase will pick up the push notification and start app.js service. App.js will use user agent API of SIP.js in order to send the register request to the OpenSIPS. OpenSIPS will forward the invite back to the SIP.js. SIP.js will use SDH or Session Description Handler APIs in order to do offer and answer with the WebRTC, React Native WebRTC engine. And after that, RTP session is established between RTP engine and WebRTC on the React Native side. You can find all the relevant reference links for these open source React Native libraries in the description box. All of this leaves us with the Softphone application, which is optimized for impeccable communication. It is fast, it is efficient, it is easy to use. We hope this gave you a good idea of the path that Softphone industry is taking. If you have any questions, please put it in the comment section or messages.